Hello friends, I welcome you in lecture number 6 on logic. In this lecture, we are going to understand these three definitions: tautology, contradiction and contingency. So these are the special type of compound propositions which satisfy certain criteria or condition. Now we are familiar with the meaning of compound proposition. If we have a proposition that is obtained by using logical connectives or logical operators, then that proposition is called compound proposition. So a compound proposition that is always true no matter what the truth values of the propositions that occur in it is called a tautology. A compound proposition that is always true is known as tautology, and a compound proposition that is always false is called a contradiction, and a compound proposition that is neither a tautology nor a contradiction is called contingency. So sometimes they can ask you to write down the definitions, so you can write in this way: compound proposition that is always true is called tautology, which is always false is called contradiction, and compound proposition that is neither tautology nor contradiction is called a contingency. Suppose we consider these two compound propositions. Suppose I want to determine the truth value of this proposition, which is compound proposition, using these two propositions P and negation of P. So we can check by using truth table. I have P and negation of P here, and I am considering this disjunction operator for this P and negation of P. Now for P there are two possibilities, true and false, and negation of P has F and T as truth values, and this OR operator is inclusive OR. That means if at least one is true, then this is going to be true. So here I have this truth value as T, therefore this is true, and because of this T, here we have T. Now we can observe this P or negation of P. Here both the truth values are true. So we can say that this compound proposition is true for all possible combinations of P and negation of P. We have taken this compound proposition, which is combination of these two propositions, and irrespective of truth values of P and negation of P, what we obtain is this compound proposition is always true. Therefore this compound proposition is a tautology. And we can check for this operator also, conjunction operator. Here I will write P and negation of P. There are two possibilities, true and false. Now for negation we have opposite, true then F, F then T. And we know that if we have AND operator, that is conjunction of two propositions, then it is true if and only if both the propositions are true. And here we have this proposition false, therefore this is false, and because P is false here, this is also false. So whatever the truth values of P and negation P are, this compound proposition is always false. Therefore it is not a tautology, it is contradiction. So using truth table also we can decide whether given compound proposition is a tautology, contradiction or contingency. We have to see in the column of that compound proposition what are the columns corresponding to that compound proposition in truth table. If we have all the values are true, then we have tautology, If we have all the values in that column are f, then we have contradiction, and if we have mixture of t and f, then we have contingency. We consider one example related to this, which was asked in GTU Winter 2021 exam. So here question is, using truth table, state whether each of the following implication is a tautology or not. So we discuss for each implication one by one. First one is P and R implies P. So I have to determine the truth table corresponding to this P and R and this conditional statement or implication. So here I have two propositions, P and R. Then I have to consider this conjunction of P and R, and after that I have to consider implication P and R implies P. And if we have two propositions, then the number of possible combinations of truth values of P and R are 4. That is, P is true, R is true, then P is true, R is false. Similarly, suppose P is false, then R is true, and P is false, R is also false. So these are the 4 different possible combinations for truth values of P and R. Here we emphasize that this P and R are not statements, but they are statement variables, because we are not having any particular statement here. We are using this P and R as general statements, therefore they are called statement variables or propositional formulas or statement formulas. Therefore we are writing all these possible truth values. If we have a particular statement, then we can say that it is either true or false, but here we have statement formulas. Now we want to find out conjunction of P and R. So for that we remember that for conjunction it is true if both the propositions or statements are true, otherwise it is false. So here there is only one possible combination in which both are true, and in all other combinations we have at least one false. Therefore this is going to be the column corresponding to truth value of P and R. Now we have to write down for this column P and R implies P. So for that we recall that suppose we have this conditional statement P implies Q, then this is true if or we remember in this way, there is only one possibility in which this is false. So this implication is false if P is true and Q is false. Now instead of P we have P and R, that is we concentrate for this column, and here we have instead of Q we have P here. So now our P here is P and R, and here instead of Q we have P. So this is going to be false if this is true and this one is false. So here we can see here this is true and P is also true, therefore we have T here. Now in all other cases this P and R has truth value F. So we know that whenever we have this conditional statement, then it is false if P is true and Q is false. But if P is false, then we don't have to worry about Q. If P is false, then this implication is always true. Therefore I am writing T here. And now I can observe that every value in the column corresponding to this compound proposition is having truth value t, therefore we can say that given compound proposition P and R implies P is a tautology. So it is very easy to decide whether given statement is a tautology or not. All we have to construct is truth table corresponding to that compound proposition, and then we have to check for the column corresponding to that statement formula. If all the values are having truth value t, then we have a tautology. Now we consider second compound proposition. First one we have discussed. Now this is a tautology. Now we check for this. P and Q implies P implies Q. So here also we have two propositions P and Q. We have this compound proposition P and Q implies P implies Q. So let me check again. P and Q implies P implies Q. So here also I am preparing the truth table. First I will write P, then Q, then I will require P and Q, then I will require P implies Q, and after that I can write the column corresponding to P and Q implies P to Q. And then as usual we have to write down different possible combinations. So for P we write T, T, F, F. For Q we write T, F, T, F. And here we have AND operator, that is conjunction of P and Q, and we know that this is true if both are true, otherwise it is false. So here we have F and F. Then we write down the column corresponding to P implies Q. We know that this is false if P is true and Q is false. So in this case it is false. Here P is true and Q is also true, therefore it is having T. And here we have P false, so in that case we consider this as true. So in short, P to Q is false in the case P is true and Q is false. In all other cases it is having truth value T. Now I have to write down this conditional statement in which we have to concentrate on the proposition P and Q, and another one is P to Q. So now I am writing for these two. So here also, if this one is true and this one is false, then only this is false. So here for first combination we have this is true and this is also true, therefore we have T. And we know that if all these are false, that is if first one is false, then in that case conditional statement is always true. So therefore all the values in this column are true, and therefore we can say that given propositional formula or statement formula P and Q to P to Q, this is also a tautology. And third one is P implies P or Q. So let's check for third one. It is P implies P or Q. So here also we have to prepare the truth table for P, Q, then P or Q, and after that column for this P implies P or Q. And for P and Q we have these possibilities T, T, F, F, then T, F, T, F, and here we have or. We know that P or Q is true if either P is true or Q is true or both are true. Here both are true, therefore it is true. Here P is true, therefore it is true. Here Q is true, therefore it is true. And here both are false, therefore it is false. And now we consider conditional statement P implies P or Q. And we know that this is false if P is false, P is true and P or Q is false. So here we can see P is true, P or Q is true, therefore this is true. Here P is true and P or Q is also true, therefore this is true. And here this is false, so this is going to be true. This is false if first one, that is P is true and P or Q is false. But here we can see whenever P is true, P or Q is true, and in this case we consider this as true. So therefore all the values in the last column are having truth value T. Therefore we can say that P2, P or Q, this is also a tautology. So in this way we can determine whether given propositional formula or statement formula is a tautology or not. If all the truth values in the column corresponding to that formula in truth table are true, then that propositional formula is a tautology, and if all the values are false, then it is a contradiction. So this is all about this session. Here we have understood that how to check whether given compound proposition is a tautology or not using truth table, and similarly we can check for contradiction and contingency also. So I stop here. Thanks for watching.